In the year 1936, beneath a sky heavy with the golden dust of ages, a group of workers moved through the sun-scorched earth southeast of Baghdad. They were excavating near a small village called Khujut Rabu, their shovels cutting through layers of sand and clay that had lain undisturbed for centuries upon centuries. The air was thick with heat, and the landscape stretched endlessly toward the horizon, a terrain that had witnessed the rise and fall of empires long before the modern world took shape. No one among them could have known that their labor would unearth something that would puzzle scientists and historians for generations to come. The excavation was taking place during the construction of a new railway, a project that required digging deep into ground that held the compressed memory of millennia. Iraq in those days was a land caught between its ancient past and an uncertain future, still finding its footing as a young nation under the watchful eyes of foreign powers. The workers spoke in hushed tones as they moved the earth, sometimes finding pottery shards and broken remnants of lives lived long ago. But on this particular day, something different emerged from the darkness below. Something that did not fit neatly into any category the archaeologists had prepared for. The objects that surfaced were small clay jars, unassuming at first glance, their exteriors weathered by the passage of more than 2,000 years. They measured roughly 5 to 6 inches in height, shaped like modest vessels one might use for storing wine or oil or some other household substance. The terracotta was a dull yellowish brown, the color of the desert itself. And to an untrained eye, they might have seemed entirely ordinary. Yet, when the excavators examined them more closely, they discovered that these jars contained something unexpected within their hollow interiors. Inside each vessel rested a copper cylinder fitted with remarkable precision into the opening of the jar. The cylinder was fashioned from a single sheet of copper that had been rolled and soldered along its seam, creating a tube that sat snugly within the clay container. At the bottom of this copper tube, a copper disc had been placed, sealing it off from one end. Suspended within the cylinder, not quite touching the copper walls, was a single iron rod that extended up through the center. The entire arrangement had been sealed at the top with a plug of bitumen, that black sticky substance the ancients extracted from the earth and used for waterproofing boats and buildings. Wilhelm König was a German archaeologist serving as the director of the National Museum of Iraq during those tumultuous years. He was a meticulous man with sharp eyes and an insatiable curiosity about the artifacts that passed through his institution. When the strange jars from Khujut Rabu arrived at the museum, König examined them with growing fascination. He turned them over in his hands, noting the careful construction, the deliberate placement of each component. Something about their design nagged at his mind, stirring a suspicion that these were not mere storage containers, but something far more purposeful. König had spent years studying the material culture of ancient Mesopotamia, and he recognized quality craftsmanship when he saw it. The copper cylinders were not hastily made, but showed evidence of skilled metalworking. The iron rods had been shaped with intention, their surfaces corroded by time, but still revealing the care with which they had been fashioned. Tolman seals were applied thoroughly, as if the creators wanted to ensure that whatever was inside the jars would remain contained. All of these details suggested that the objects served some specific function, though what that function might be remained elusive. As König studied the artifacts in the quiet halls of the museum, he began to form a hypothesis that seemed almost too extraordinary to voice aloud. The arrangement of copper and iron, separated by space within a sealed vessel, reminded him of something he had seen in his own modern world. It resembled the basic structure of a galvanic cell, the kind of simple battery that had been developed in Europe during the early 19th century. Could it be possible, König wondered, that the ancients had discovered the principles of electricity 2,000 years before Alessandro Volta constructed his famous pile? The idea was radical, perhaps even heretical, to the established understanding of technological history. Conventional wisdom held that electricity was a modern discovery, the product of Enlightenment science and the systematic experimentation of European researchers. It's the notion that craftsmen in ancient Mesopotamia, might have harnessed electrical current, challenged fundamental assumptions about the progress of human knowledge. Yet, König could not shake the feeling that he was looking at something genuinely anomalous, a puzzle piece that did not fit the accepted picture of the past. He published his observations in a paper that circulated among his colleagues, describing the construction of the jars and tentatively proposing that they might have functioned as primitive batteries. The response was mixed, as one might expect for such a provocative claim. Some scholars dismissed the idea outright, arguing that there was no evidence the ancients understood anything about electricity. Others expressed cautious interest, acknowledging that the physical structure of the artifacts was indeed peculiar. The debate had begun, a conversation that would continue for decades without reaching any definitive conclusion. To understand why these objects might have existed at all, one must first appreciate the world into which they were born. The region we now call Iraq was once the cradle of human civilization, the Fertile Crescent where agriculture first took root and cities first rose from the plain. The Tigris and Euphrates rivers flowed through this land like twin arteries, bringing water and life to the settlements that grew along their banks. Here, the Sumerians invented writing, pressing wedge-shaped marks into soft clay tablets. Here, the Babylonians charted the movements of the stars and developed mathematics that we still use today. By the time the mysterious jars were created, it's likely during the Parthian period between 250 years before the Common Era and 224 years after it, this region had already accumulated thousands of years of accumulated wisdom. The Parthians were inheritors of all that had come before, drawing upon Persian and Greek and Mesopotamian traditions in a rich cultural synthesis. Their empire stretched from the mountains of present-day Iran to the borders of the Roman world, controlling vital trade routes that connected east and west. Goods and ideas flowed through their territories like water through channels, bringing knowledge from distant lands. The village of Khujut Rabu, where the jars were discovered, sat near the ancient city of Ctesiphon, which served as one of the Parthian capitals. This was no remote backwater, but a place of significance, connected to the great networks of commerce and culture that crisscrossed the ancient world. Craftsmen in such a location would have had access to materials and techniques from across the known world, would have worked with metals brought from distant mines, learned methods passed down through generations, experimented with combinations of substances in ways we can only imagine. The copper used in the cylinders would have been readily available, as copper mining and working had been practiced in this region for millennia. The iron rods presented a more interesting challenge, for iron was harder to smelt and shape than copper or bronze. Yet, by the Parthian period, ironworking had become widespread. Skilled smiths could produce rods and tools of considerable quality. The bitumen that sealed the vessels was practically a local resource, seeping up from the earth in places where petroleum deposits lay close to the surface. All the materials were there, waiting to be combined by hands that understood their properties. König speculated about what liquid might have filled the jars to complete the circuit. Traces of residue suggested that some acidic substance had once been present, perhaps vinegar or wine or the juice of citrus fruits. Any of these will provide the electrolyte necessary for a galvanic reaction. It's the medium through which ions could flow between the copper and iron electrodes. With such a liquid in place, the completed device would generate a small but measurable electrical current, perhaps 1 or 2 volts at most. Not enough to power anything we would recognize as a machine, but enough to produce effects that might have seemed magical to those who witnessed them. The world of ancient Mesopotamia was one where magic and technology were not yet divided into separate categories. Priests and craftsmen worked with substances and processes that blurred the line between the natural and the supernatural. Metallurgists transformed dull ore into gleaming metal through secret recipes passed from master to apprentice. Healers mixed herbs and minerals into potions that could relieve pain or induce visions. Artisans created objects of such beauty and precision that they seemed to carry divine blessing. In such a world, a device that could produce a tingling sensation or make metal stick to metal might have been understood as something sacred. As the sun set over Baghdad, in those years before the great wars that would reshape the region, König continued to ponder the meaning of what he had found. The artifacts rested in the museum, their secrets locked within their corroded forms. Outside, the modern city hummed with life, automobiles and electric lights, and all the conveniences that electricity had brought to the 20th century. Few who passed by the museum walls knew that inside lay objects which might suggest that the story of that power was far older and stranger than anyone had supposed. The mystery of the Baghdad Battery, as the artifacts would come to be known, had entered the world. It would travel far beyond the walls of that museum, sparking imagination and controversy wherever the story was told. Scientists would attempt to replicate the devices, testing whether they could indeed generate current. Historians would argue about their purpose, proposing theories that ranged from the practical to the mystical. Skeptics would offer alternative explanations, suggesting that the unusual construction was merely coincidental. And through it all, the little clay jars would remain silent, keeping their secrets as they had kept them for 2,000 years. In the decades that followed König's discovery, the world would change dramatically. Wars would sweep across this ancient land, bringing destruction and displacement. The museum that housed the batteries would be looted, and some of the precious artifacts would disappear into the chaos of conflict. Yet the questions that König raised would persist, passed from one generation of curious minds to the next. What did the ancients know that we have forgotten? What capabilities did they possess that we have failed to recognize? And what other wonders might still lie buried beneath the sands, waiting for future excavators to bring them back into the light? These are the questions that draw us into the mystery, that invite us to look more closely at the past and consider possibilities we might otherwise dismiss. The Baghdad Battery stands as a reminder that history is not a simple story of progress from primitive to sophisticated, from ignorance to knowledge. The path of human discovery is winding and uncertain, full of dead ends and forgotten achievements. What one generation learns, the next may lose. What one civilization masters, another may never discover. The only certainty is that we do not know everything, and that the past holds surprises we have yet to uncover. So let us journey together into this mystery, following the trail of evidence and speculation that the Baghdad Battery has left behind. Let us examine the artifacts with fresh eyes, consider the theories that have been proposed, and weigh the arguments of believers and skeptics alike. Along the way, we may find that the story reveals as much about us and our assumptions as it does about the ancient craftsmen who created these enigmatic objects so very long ago. The empire that created these mysterious objects has largely faded from popular memory, overshadowed by the more celebrated civilizations that came before and after it. Yet, the Parthian realm was one of the great powers of the ancient world, a vast dominion that stretched across the heart of Asia for nearly 500 years, from the middle of the 3rd century before the Common Era until the early decades of the 3rd century after it. The Parthians controlled territories that encompassed modern Iran, Iraq, and portions of Afghanistan, Pakistan, Syria, and Turkey. They stood as equals and rivals to Rome itself, the only Eastern power that consistently checked the expansion of the Mediterranean superpower. The Parthians emerged from the steppes of Central Asia, a nomadic people who swept down into the declining Seleucid Empire and made it their own. They were master horsemen, famed for their cavalry tactics and their ability to strike swiftly across vast distances. But their mounted archers could loose arrows with deadly accuracy while riding at full gallop. In their heavy cataphracts were armored warriors who could break enemy formations like iron waves crashing against sand. Yet, for all their martial prowess, the Parthians were not merely conquerors. There were also administrators, traders, and patrons of art and learning who presided over a flourishing, multicultural civilization. The Parthian approach to ruling their diverse territories was remarkably flexible for the ancient world. Rather than imposing a single uniform culture upon their subjects, they allowed considerable autonomy to the various peoples under their dominion. Greek cities continued to operate with their traditional institutions. Mesopotamian temples maintained their ancient rituals. Persian aristocrats preserved their ancestral customs. This tolerance created a realm where different traditions could coexist and intermingle, where ideas and techniques could flow freely across cultural boundaries. It was precisely this environment of exchange that might have given rise to innovations like the Baghdad Battery. At the crossroads of their empire lay Mesopotamia, the land between the rivers that had been civilized for longer than anywhere else on earth. By the Parthian period, this region had accumulated layer upon layer of knowledge. The accumulated wisdom of Sumerians and Akkadians and Babylonians and Assyrians and Persians and Greeks. Libraries held clay tablets inscribed with astronomical observations stretching back thousands of years. Workshops preserved techniques for working metal and glass and clay that had been refined over countless generations. Scholars studied texts in multiple languages, translating and synthesizing the learning of many cultures into new combinations. The city of Ctesiphon, which lay near where the Baghdad Battery was discovered, exemplified this rich cultural mixing. Founded on the banks of the Tigris River, it grew to become one of the largest cities in the ancient world, with a population that may have reached several 100,000 at its peak. Its markets drew merchants from every direction, bringing goods from China and India and Arabia and the Mediterranean. Its streets echoed with dozens of languages, and its neighborhoods housed communities of Persians and Greeks and Jews and Aramaic speakers and many others. In such a cosmopolitan setting, knowledge could travel as easily as silk and spices. The trade routes that passed through Parthian territory were the arteries of the ancient world, carrying not just material goods, but also ideas and innovations. The Silk Road, that legendary network of paths connecting east and west, ran directly through Parthian lands. Caravans laden with Chinese silk moved westward toward Roman markets, while glassware and textiles flowed eastward in return. But alongside these physical commodities traveled something less tangible and perhaps more valuable: the accumulated knowledge of distant civilizations, shared through conversation and demonstration in the movement of skilled craftsmen from one land to another. Consider for a moment the remarkable range of expertise that converged in this region during the Parthian centuries. From China came techniques of silk weaving and papermaking and the first stirrings of alchemical experimentation. From India came mathematical innovations, including the concept of zero and sophisticated metallurgical processes. From Egypt came traditions of glassmaking and chemical manipulation that stretched back to the time of the pharaohs. From Greece came philosophical inquiry and systematic approaches to understanding the natural world. All of these streams of knowledge flowed through Parthian territory, available to anyone curious enough to learn from foreign visitors. Their smiths produced steel of remarkable quality, forging weapons and tools that were prized throughout the ancient world. Their engineers constructed irrigation systems and roads and bridges that allowed their empire to function across vast distances. They were practical people who valued knowledge that worked, techniques that produced tangible results in the physical world. It is within this context of technological sophistication and cultural exchange that we must understand the Baghdad Battery. If the artifacts were indeed electrical devices, they did not emerge from nowhere. They would have been the product of a long tradition of experimentation with metals and chemicals, of careful observation of natural phenomena, of trial and error stretching back through countless generations. The Parthian craftsman who assembled copper and iron within a clay jar was building upon foundations laid by predecessors whose names have been lost to time. The practice of electroplating, which some researchers believe may have been the purpose of the Baghdad Battery, would have fit naturally into this world of sophisticated metalwork. Gilding objects with thin layers of gold or silver was highly valued in the ancient world, and various techniques existed for achieving this effect. The simplest method was fire gilding, which involved applying an amalgam of gold and mercury to an object and then heating it to drive off the mercury up. But this process was dangerous, as mercury fumes are highly toxic. An electrochemical method would have offered a safer and more controlled alternative. Evidence suggests that ancient craftsmen did indeed produce gilded objects of remarkable quality, with gold layers so thin and even that they seemed to exceed what fire gilding alone could achieve. Some researchers have pointed to specific artifacts from Mesopotamia that display characteristics consistent with electroplating, though this interpretation remains controversial. Some researchers have proposed that the ancient Egyptians possessed knowledge of electricity, pointing to unusual images in temple carvings that they interpret as depicting electrical devices. Others have suggested that the Ark of the Covenant, described in the Hebrew Bible, might have functioned as a kind of electrical capacitor. While these theories remain highly speculative, they speak to a broader intuition that the ancients may have understood more about the physical world than we typically give them credit for. What is certain is that the Parthian world possessed the raw materials and the technical expertise necessary to create functional galvanic cells. Copper and iron were readily available and widely worked. Acidic substances like vinegar and fruit juice were common household items. Bitumen for sealing vessels could be gathered from natural seeps throughout the region, and the tradition of encasing precious substances in clay containers stretched back to the very beginning of Mesopotamian civilization. All the pieces were in place, waiting only to be combined in the right configuration. The intellectual climate of the Parthian period would also have encouraged experimentation with unusual phenomena. A craftsman who noticed a strange tingling sensation when handling certain combinations of metals might have been motivated to explore the phenomenon further. We know that static electricity was observed and documented in the ancient world. The Greek philosopher Thales of Miletus, writing in the 6th century before the Common Era, noted that amber rubbed with fur could attract small objects like feathers and straw. The Greeks even named this phenomenon after their word for amber, electron, giving us the modern term electricity. While static electricity is quite different from the galvanic current that a battery produces. Awareness of such phenomena might have primed ancient investigators to recognize and explore other electrical effects when they encountered them. The transfer of knowledge in the ancient world was often mysterious and indirect, passing through channels that left little trace in the historical record. Or consider the mystery of Damascus steel, the legendary material from which the finest swords of the medieval Islamic world were forged. These blades were renowned for their sharpness, their flexibility, and the beautiful watered patterns on their surfaces. Yet, by the 18th century, the technique for making true Damascus steel had been lost. And despite centuries of effort, modern metallurgists have only recently begun to understand how it was produced. The knowledge existed for hundreds of years and then simply vanished, leaving only the artifacts themselves as evidence of what had once been possible. The Baghdad Battery may represent another such lost technique, a piece of ancient knowledge that was discovered, utilized for some particular purpose, and then forgotten when the social conditions that supported it changed. The fall of the Parthian Empire in the 3rd century of the Common Era brought disruption and displacement to the region. The Sassanid Persians, who succeeded them, had different priorities and different traditions. Knowledge that was not written down or widely shared could easily have perished in the transition, surviving only in the physical form of artifacts buried beneath the earth. As we contemplate the world that produced these enigmatic objects, we begin to understand why the mystery of the Baghdad Battery is so compelling. It is not simply a question of whether the ancients had electricity. It is a question of how much we truly know about the past, how much has been lost in the vast stretches of unrecorded time. How many discoveries might have been made and forgotten before the modern age of documentation began? The little clay jars from Khujut Rabu are windows into this larger mystery, invitations to wonder about all that we do not and perhaps cannot know. The Parthian Empire has crumbled into dust, its cities buried beneath later settlements, its records largely destroyed by the passage of time. But the questions it poses remain vital and alive, challenging us to think more carefully about the relationship between past and present, between what we assume and what we actually know. In the silence of the artifacts, we hear an echo of vanished voices. It's craftsmen and scholars who lived and worked and wondered about the world just as we do today. To understand why these artifacts have generated such enduring fascination, one must examine them closely, attending to the details of their construction with the same care that the original craftsmen brought to their creation. The objects that emerged from the earth near Khujut Rabu were not crude or hastily assembled. They displayed a level of precision and intentionality that spoke of skill refined through long practice, of knowledge accumulated across generations, of purpose that extended beyond mere accident or improvisation. The outer vessel was fashioned from terracotta, that humble material of fired clay that has served human needs since the earliest days of settled civilization. Each jar stood approximately 5 to 6 inches tall, with a body that swelled gently outward from a narrow base before tapering again toward the mouth. The proportions were pleasing to the eye, balanced and symmetrical in a way that suggested the potter's wheel rather than hand shaping alone. The walls were of moderate thickness, sturdy enough to protect the contents within, yet not so heavy as to make the vessel cumbersome to handle. The clay itself bore the characteristic color of the Mesopotamian earth, a warm yellowish brown that spoke of the alluvial deposits laid down by the Tigris and Euphrates over countless millennia, fired at temperatures sufficient to harden the material, but not so high as to vitrify it completely. The terracotta retained a slightly porous quality that would have allowed some exchange of air and moisture with the environment. This porosity would later become significant in discussions of whether the vessels could have held liquid for extended periods without the seal provided by the bitumen stopper. The mouth of each jar was wide enough to admit a hand, allowing the interior components to be assembled and later removed if necessary. The rim was finished with reasonable smoothness, providing a surface against which the stopper could seat securely. Around the exterior of some specimens, faint traces of decoration could be discerned, though weathering and the passage of time had worn away most surface details. Whether these marks represented simple identification, symbols, or more elaborate ornamentation remained difficult to determine. Within this ceramic shell rested the copper cylinder, the component that first drew King's attention and sparked his remarkable hypothesis. The cylinder was formed from a single sheet of copper that had been rolled into a tube and sealed along its length with a soldered seam. The metalwork was clean and competent, showing none of the crudeness one might expect from primitive fabrication. Whoever made this piece understood copper and knew how to work it with precision. The dimensions of the copper tube were carefully matched to the interior of the clay vessel, fitting snugly within the opening while leaving a small gap between the metal and the ceramic walls. This gap would have been essential if the device functioned as a battery, providing space for electrolyte to circulate around the electrode. The length of the cylinder extended nearly to the bottom of the jar, maximizing the surface area available for electrochemical reaction. These proportions did not appear accidental, but rather suggested deliberate optimization for some specific purpose. At the bottom of the copper cylinder, a circular disc of the same metal had been fitted and sealed, creating a closed chamber within the tube. This disc was attached with evident care, the joint tight enough to prevent leakage of any liquid that might be placed inside. The craftsmanship required to achieve such a seal with ancient tools and techniques was not trivial. The kind of worker who accomplished it possessed genuine skill, the kind that comes only from extensive training and practice. The copper itself showed the greenish patina of age, the surface oxidation that develops over centuries of exposure to air and moisture. Beneath this patina, the metal remained sound, its structural integrity preserved despite the passage of 2 millennia. Copper is among the more durable of common metals, resistant to the corrosion that destroys iron and the tarnishing that dims silver. The choice of copper for the cylinder component may have reflected awareness of this durability, a desire to create something that would last. Suspended within the copper cylinder, positioned precisely at its center without touching the surrounding walls, was the iron rod that completed the essential structure. This rod extended from near the bottom of the cylinder up through the top, projecting slightly above the rim of the copper tube. The positioning was critical. Had the iron touched the copper at any point, the two metals would have formed a direct electrical connection, short-circuiting the cell and preventing any useful current from flowing through an external path. The iron rod showed considerably more deterioration than the copper components, its surface rough and pitted with the rust that inevitably attacks ferrous metals in moist environments. In some specimens, the corrosion was so extensive that the original dimensions of the rod could only be estimated, yet enough remained to confirm that the iron had been shaped with intention, worked into a regular cylindrical form, rather than simply broken or cut from a larger piece. The rod was not a random inclusion, but a deliberately manufactured component. Holding the iron rod in its central position, preventing it from falling against the copper walls, was a plug of bitumen that sealed the top of the assembly. Bitumen, sometimes called natural asphalt, is a sticky black substance that seeps from the earth in regions where petroleum deposits lie close to the surface. The ancient Mesopotamians had used bitumen for thousands of years before these artifacts were created, applying it to waterproof boats and baskets, to seal buildings against rain, and to bind bricks together in their monumental constructions. The bitumen plug served multiple functions in the Baghdad Battery configuration. Gate held the iron rod firmly in place, maintaining the crucial separation between the two electrodes. It sealed the top of the vessel, preventing evaporation of any liquid contents and protecting the interior from contamination. And it provided electrical insulation, ensuring that current could not flow directly from iron to copper through the stopper itself. All of these functions would have been necessary for an effective galvanic cell, and all were accomplished by this single, elegantly simple component. When König examined the bitumen, he noted that it appeared to have been applied while warm and pliable, molded around the iron rod and pressed into the mouth of the copper cylinder before hardening as it cooled. The technique was identical to that used in countless other applications throughout the ancient Near East, requiring no specialized knowledge beyond what any competent craftsman would have possessed. Yet, the specific application here, creating an insulating seal that maintained electrode separation, suggested awareness of requirements that went beyond simple waterproofing. The complete assembly, when considered as a whole, presented a configuration that was difficult to explain as accidental or purposeless. Each component related to the others in ways that seemed functionally significant. The clay vessel protected and contained. The copper cylinder provided one electrode with maximum surface area. The iron rod provided the other electrode, carefully isolated from direct contact. The bitumen, sealed and insulated. Remove any element or change its arrangement, and the device would lose whatever capability it possessed. König measured and documented the artifacts with the meticulous care of his training, recording dimensions and materials and construction details that would allow future researchers to evaluate his hypothesis. His notes describe variations among the different specimens, suggesting that these were not mass-produced items stamped from a single mold, but individual creations, each slightly different from the others. This variation was consistent with handicraft production, where skilled workers produced similar but not identical objects according to a general pattern. The weight of the assembled devices was modest, light enough to be easily handled and transported. A single battery could be carried in one hand, moved from place to place as needed for whatever purpose it served. This portability would have been advantageous for medical applications, where the device might need to be brought to patients, or for craft applications, where different workstations might require access to electrical current at different times. Some researchers noted that the configuration of the Baghdad Battery bore a remarkable similarity to simple galvanic cells that any modern chemistry student might construct as a classroom exercise. The basic principle is the same: two dissimilar metals separated by an electrolyte solution, differing only in the specific materials employed in the container that houses them. This similarity might be coincidental, or it might reflect convergent discovery, different peoples arriving independently at the same solution to the same problem. The craftsmanship evident in the artifacts spoke of a manufacturing tradition that had developed over time, refined through repetition and improvement. No one creates such objects on their first attempt. The skills required to roll copper sheet into a precise cylinder, to solder seams watertight, to shape iron rod to specification, to apply bitumen as both sealant and insulator. All of these would have been developed through practice and passed from master to apprentice across generations. The Baghdad Battery was not an invention, but an inheritance, the product of accumulated knowledge. Questions arose about how many such devices had originally existed and what had happened to the others. The specimens recovered near Khujut Rabu might represent only a tiny fraction of a much larger production, most of which have been lost to decay or destruction or simple dispersal over the centuries. Alternatively, they might be rare objects from the beginning, created in small numbers for specialized purposes, known only to a select group of practitioners. The archaeological record provided no definitive answer. The physical evidence, examined and re-examined over the decades since King's initial observations, has never yielded a clear verdict on the purpose of these enigmatic objects. The construction is consistent with the battery hypothesis, but does not prove it. The arrangement could serve other functions that we have not identified or have incorrectly dismissed. The artifacts themselves remain mute, offering their form for inspection, but withholding the intentions of their makers. What the physical examination does establish beyond reasonable doubt is that these were not casual or accidental assemblages. Someone designed them, someone manufactured them with skill and care. Someone considered how the components should relate to one another and achieved that relationship through deliberate effort. Whatever the Baghdad Battery was meant to do, it was meant to do something. The purpose may be lost to us, but the purposefulness is evident in every detail of construction. The clay jars sit in their display cases or storage boxes, weathered by time, but still recognizable as products of human intention. They bridge the vast gulf between our world and theirs, tangible connections to craftsmen who lived and worked 2,000 years ago. We cannot ask them what they made or why they made it. We can only examine what remains and wonder, bringing our modern knowledge to bear on ancient objects in hopes of understanding what our predecessors achieved in an age we can barely imagine. The examination continues. Each generation of researchers bringing new techniques and new questions to the same enduring mystery. Perhaps someday a discovery will illuminate what remains dark, providing the key that unlocks the secret of these remarkable artifacts. Until then, they wait in silence, as they have waited for 20 centuries. Patient witnesses to the limits of human knowledge and the persistence of human curiosity. The transformation of these curious artifacts from mere archaeological oddities into objects of genuine scientific interest began in earnest when researchers started asking a simple but profound question. Could these ancient vessels actually work? Could they truly generate electrical current, as Wilhelm König had tentatively suggested? The answer to that question would require moving beyond speculation and into the realm of practical experimentation, building replicas and testing them under controlled conditions to see what the ancients might have achieved. The first serious attempt to replicate the Baghdad Battery came in 1940, just a few years after Kitts published his observations. Willard F.M. Gray, an engineer working at the General Electric High Voltage Laboratory in Pittsfield, Massachusetts, constructed a copy of the device based on the descriptions and measurements that had been published. Gray was not an archaeologist, but a practical man who worked with electricity every day. And he approached the question with the straightforward curiosity of someone who wanted to know if a thing would function as claimed. Gray assembled his replica with care, following the specifications of the original artifacts as closely as possible. He fashioned a copper cylinder of the appropriate dimensions, inserted an iron rod, and sealed the assembly within a clay vessel using an asphalt-like substance to mimic the bitumen of the originals. The construction was simple enough that any reasonably skilled craftsman could have accomplished it with materials readily available in the ancient world. The question was, what would happen when he added the final ingredient, the liquid electrolyte that would complete the circuit? When Gray filled his replica with a solution of copper sulfate, a substance that could have been produced in antiquity, the results were immediate and unmistakable. The device generated an electrical current, producing approximately 2 volts of power. This was a modest amount by modern standards, barely enough to light a small bulb or produce a faint, tingling sensation on the skin, but it was real, measurable electricity produced by a device whose basic design was over 2,000 years old. The implications were staggering to contemplate. To understand why this simple arrangement of metals and liquid produces electricity, we must delve briefly into the science of galvanic cells. The phenomenon was first systematically studied by Luigi Galvani in the late 18th century, when he observed that the muscles of dead frogs would twitch when touched by 2 different metals. Galvani initially believed he had discovered a form of animal electricity inherent to living tissue. It was Alessandro Volta who correctly identified the true source of the current, demonstrating that the electricity arose from the contact between dissimilar metals in the presence of a moist conductor. The principle underlying all batteries is elegantly simple. When 2 different metals are placed in an electrolyte solution, a chemical reaction occurs at the surface of each metal. One metal, called the anode, tends to lose electrons through a process of oxidation. The other metal, called the cathode, tends to gain electrons through a process of reduction. If the 2 metals are connected by a wire or other conductor, key electrons will flow from the anode to the cathode, creating an electrical current. The electrolyte solution allows ions to move between the electrodes, completing the circuit and maintaining the flow of charge. In the case of the Baghdad Battery, the iron rod serves as the anode, and the copper cylinder serves as the cathode. Iron is more reactive than copper, meaning it has a greater tendency to release electrons. When both metals are immersed in an acidic solution, the iron begins to dissolve very slowly, releasing positively charged iron ions into the liquid, while electrons flow through any external connection to the copper. The process continues until the iron is consumed or the chemical conditions change sufficiently to halt the reaction. The electrolyte used in the original devices remains a subject of speculation, as no liquid residue survived the millennia of burial. Gray used copper sulfate in his experiments, but other researchers have achieved similar results with substances that would have been far more accessible to ancient craftsmen. Vinegar, which is essentially a dilute solution of acetic acid, works quite well as an electrolyte and would have been a common household item throughout the ancient world. Wine that is turned sour would serve the same purpose. Fresh grape juice, lemon juice, or any other acidic fruit extract would also function effectively. Subsequent experiments by other researchers confirmed and expanded upon Gray's findings. In 1947, a German scientist named Arne Egerbricht conducted tests using grape juice as the electrolyte, achieving results comparable to those obtained with more exotic solutions. Brecht was particularly interested in the possibility that the batteries had been used for electroplating, and his experiments demonstrated that the voltage produced was indeed sufficient to deposit thin layers of gold onto silver objects. The process was slow, requiring many hours of continuous current, but it was definitely possible. The physics of the situation allows us to calculate what the ancients could have achieved with these devices. A single Baghdad battery producing 1 to 2 volts would have been sufficient for certain applications, but inadequate for others. However, multiple cells could be connected in series, with the copper terminal of one linked to the iron terminal of the next, multiplying the total voltage available. 10 cells connected in this manner would produce 10 to 20 volts, enough to create noticeable physiological effects or to drive more robust electrochemical processes. The discovery that the Baghdad Battery actually worked as an electrical device opened up a cascade of further questions. If the ancients could produce electricity, what did they use it for? Did they understand what they had created, or was it merely a curious phenomenon they exploited without comprehending its nature? Were there other electrical devices in antiquity that have simply not survived or not been recognized for what they were? Each answer seemed to generate a dozen new mysteries. Gray's experiments attracted attention from both the scientific community and the popular press. Here was a story that captured the imagination. It's the idea that people living 2,000 years ago might have possessed knowledge that we assumed was the exclusive province of modern civilization. Newspapers and magazines ran articles about the ancient battery, introducing the concept to a wide audience that found it both fascinating and slightly unsettling. The comfortable narrative of continuous human progress. With each generation advancing beyond the achievements of its predecessors, suddenly seemed less certain. The scientific community was more cautious in its response, as scientists tend to be when confronted with claims that challenge established understanding. Many researchers acknowledged that the devices could generate electricity, but questioned whether the ancients had actually used them for that purpose. Perhaps the resemblance to a battery was coincidental. They suggested perhaps the components had been assembled for some entirely different reason that we have failed to identify. Correlation does not equal causation, and the fact that something could work in a certain way does not prove that it was intended to work that way. This skepticism was not unreasonable. The history of archaeology is littered with examples of modern observers projecting their own assumptions onto ancient artifacts, seeing familiar functions where none existed. A stone shaped like a wheel might be interpreted as evidence of wheeled vehicles when it was actually used as a grindstone or a decorative object. A carved bone might be called a musical instrument based on superficial resemblance when it was truly a tool for working leather or a ritual implement. Scientists had learned to be wary of such interpretive leaps, yet the battery hypothesis had something that many such speculative interpretations lacked: experimental verification. The devices worked, produced electricity when assembled and filled with electrolyte. This was not a matter of interpretation or imagination, but of measurable, reproducible physical phenomena. Whatever the original purpose of the Baghdad Battery might have been, the fact that it functioned as an electrical cell could not be dismissed. The question shifted from whether the technology was possible to why it would have been developed and what it might have been used for. The voltage measurements from various replica experiments have been remarkably consistent over the decades. Different researchers, using different materials and methods, have all reported results in the range of 1 to 2 volts per cell, with currents measured in milliamperes. These numbers defined the boundaries of what the technology could accomplish. Tasks requiring high voltage or high current would have been impossible with such devices, but applications requiring only modest electrical input, sustained over extended periods, would have been well within reach. One particularly intriguing aspect of the Baghdad Battery is how closely its design mirrors the optimal configuration for a simple galvanic cell. The copper cylinder provides a large surface area for the cathodic reaction. The iron rod suspended in the center without touching the copper walls ensures that the current must flow through the electrolyte rather than short-circuiting directly. The sealed container prevents evaporation of the electrolyte and protects the device from contamination. Every element of the design seems purposeful, as if the creator understood intuitively or through experimentation what was needed for the device to function efficiently. This apparent optimization is difficult to explain if the battery function was merely accidental. Random assemblages of materials do not typically achieve efficient configurations by chance. The design of the Baghdad Battery suggests deliberate refinement, the kind of improvement that comes from repeated testing and modification over time. Someone, at some point, must have experimented with different arrangements and discovered that this particular configuration worked best. That process of discovery implies awareness of the phenomenon being exploited, even if the theoretical understanding was lacking. The early experiments with replica batteries also revealed the limitations of the technology. The current produced was weak and tended to diminish fairly quickly as the electrolyte became depleted or the electrodes became coated with reaction products. Maintaining a steady output would have required periodic replacement of the liquid and cleaning or replacement of the iron rod. These practical constraints would have shaped how the devices could be used, favoring applications that required only intermittent or low-level electrical input. As news of the experiments spread through the scientific world and beyond, the Baghdad Battery became a touchstone for debates about ancient technology and lost knowledge. Some saw it as proof that our ancestors were far more sophisticated than we typically assume. Others viewed it as an interesting curiosity that had been overinterpreted by enthusiasts eager to find mysteries in the ancient world. Both camps could point to evidence supporting their positions, and neither could definitively prove the other wrong. What remained undeniable was the simple fact that the devices worked when assembled according to the ancient specifications and filled with an appropriate electrolyte. Cutting, they generated electrical current. This was not legend or myth or speculation, but demonstrable physical reality. Whatever we might think about the intentions or knowledge of the ancient craftsmen, we must contend with the fact that they created something functional, something that bridges the vast gulf of time between their world and ours through the universal language of physics. The experiments of Gray and Egebrecht and the many researchers who followed them transformed the Baghdad Battery from a museum curiosity into a genuine scientific puzzle. They established the baseline parameters of what the technology could do and opened the door to serious investigation of what it might have been used for. The next phase of inquiry would focus on applications, on identifying purposes for which ancient electricity might have served, and on searching for evidence that such applications had actually existed in the ancient world. Among all the proposed applications for the Baghdad Battery, none has captured the imagination quite like the theory that these devices were used for electroplating. The process of depositing thin layers of one metal onto the surface of another through the action of electrical current. This hypothesis offers something that many alternative explanations lack: a practical purpose that would have been genuinely valuable in the ancient world, and that falls within the demonstrated capabilities of the technology. If the ancients did possess electrical knowledge, electroplating provides a compelling reason why they would have developed and preserved it. The art of gilding, covering objects with thin layers of gold or silver, was highly prized throughout antiquity. Gold represented wealth, power, and divine favor in cultures around the world. A gilded object carried symbolic weight far beyond its material value, communicating status and sanctity to all who beheld it. Temples glittered with golden ornaments. Kings and queens wore gilded jewelry and carried gilded implements. Even everyday objects might be enhanced with a thin coating of precious metal, transforming the ordinary into something luminous and special. The traditional method for gilding in the ancient world was fire gilding, also known as mercury gilding or amalgam gilding. In this process, Gold is dissolved in mercury to create a paste-like amalgam that can be applied to the surface of another metal, typically silver or bronze. The coated object is then heated over a fire, causing the mercury to vaporize and leave behind a thin layer of pure gold bonded to the underlying surface. The technique produces beautiful results with gold layers that are smooth, even, and remarkably durable. Yet fire gilding carried a terrible cost. Mercury vapor is highly toxic, attacking the nervous system and causing a constellation of symptoms that ancient craftsmen must have observed without understanding their cause. Tremors, mood disturbances, cognitive impairment, and eventually death awaited those who practiced the trade for extended periods. Workshops where fire gilding was performed would have been hazardous environments. Handy artisans who worked in them would have paid with their health and their lives for the beautiful objects they created. If an alternative method existed that could achieve similar results without the poisonous fumes, ancient craftsmen would have had every reason to adopt it. Electroplating offers exactly such an alternative. By passing electrical current through a solution containing dissolved gold, thin layers of the precious metal can be deposited onto a cathode immersed in the solution. The process requires no mercury, produces no toxic vapors, and can be controlled with considerable precision. The only requirement is a source of electrical current, which the Baghdad Battery could provide. The electroplating hypothesis gained significant support from the experiments of Arne Ekebrecht, who demonstrated in the 1970s that replica Baghdad batteries could indeed deposit gold onto silver objects. Ekebrecht filled his batteries with grape juice, a mildly acidic electrolyte that would have been readily available in the ancient world. He then connected the battery to a small silver figurine suspended in a solution of gold chloride. Over the course of several hours, a thin but visible layer of gold accumulated on the surface of the figurine, transforming its appearance from silver to golden. The implications of Ekebrecht's experiment were profound. Here was tangible evidence that the technology could accomplish something of genuine practical value, something that ancient craftsmen would have had strong motivation to pursue. The gilded figurine was not merely a laboratory curiosity, but a demonstration of economic potential. If ancient goldsmiths had discovered this technique, they could have produced gilded objects more safely and perhaps more efficiently than their competitors who relied on fire gilding alone. Supporters of the electroplating hypothesis point to various artifacts from the ancient world that display characteristics consistent with electrochemical deposition. Some gilded objects show gold layers of remarkable thinness and uniformity, qualities that are easier to achieve through electroplating than through traditional methods. The gold seems to have been deposited atom by atom, building up gradually into a coating that follows every contour of the underlying surface with perfect fidelity. Such results, while not impossible with fire gilding, are more naturally explained by electrochemical processes. The region where the Baghdad Battery was discovered has yielded numerous examples of gilded objects from the Parthian period and earlier. Silver jewelry with gold accents, bronze figurines with golden surfaces, ritual vessels, and decorative items of various kinds all testify to the importance of gilding in local craft traditions. These objects would have required substantial quantities of gold and considerable skill to produce. The goldsmiths who made them were masters of their trade, working at the highest levels of their profession. Some researchers have suggested that electroplating might have been a closely guarded trade secret, known only to select guilds or families who passed the knowledge from generation to generation. This pattern of restricted transmission was common for valuable techniques in the ancient world, where competitive advantage depended on keeping methods confidential. A goldsmith who could produce superior gilding through electrical means would have had every incentive to conceal the source of his advantage, teaching the technique only to trusted apprentices who would continue the tradition. The secrecy hypothesis would explain why no written records of ancient electroplating have survived. Technical knowledge in antiquity was often transmitted orally and through hands-on demonstration, rather than through written manuals. A craft secret that was never committed to writing could easily be lost when the chain of transmission was broken, leaving no documentary evidence that it had ever existed. The Baghdad Battery itself might be the only surviving witness to a technique that was once widely practiced, but carefully hidden from outside observers. Critics of the electroplating hypothesis raised several objections that deserve consideration. The process demonstrated by Eggebrecht was extremely slow, requiring many hours to deposit a visible layer of gold. Ancient craftsmen working under commercial pressure might have found this pace unacceptable, preferring the faster, if more dangerous method of fire gilding. The time required to electroplate a single object might have exceeded the patience of customers and the economic constraints of workshop production. Furthermore, electroplating, as demonstrated with Baghdad Battery replicas, works best with gold chloride solutions, which require chemical processing to prepare. While such solutions could theoretically have been produced in antiquity using techniques available at the time, no evidence has been found that ancient craftsmen actually made them. The chemistry involved is not trivial, and the absence of any reference to such processes in surviving texts is troubling for the hypothesis. There is also the question of why electroplating technology, if it existed, did not spread more widely or leave more obvious traces in the archaeological record. Useful innovations typically diffuse through populations as people observe their advantages and seek to adopt them. The wheel, bronze working, iron smelting, and countless other technologies spread across vast regions once they were developed. Electroplating offered real advantages over fire gilding. We might expect to find evidence of its use across the ancient world, rather than in a single obscure site in Iraq. Defenders of the hypothesis respond that the conditions for technological diffusion are not always present. A technique that requires specialized equipment and knowledge might remain confined to a small group of practitioners who lack the means or motivation to spread it more widely. The fall of empires, the disruption of trade routes, the loss of key individuals who held essential knowledge. Any of these factors could have interrupted the transmission of electroplating technology before it had a chance to become widespread. The question of whether ancient goldsmiths actually used electrical gilding remains unresolved, suspended between tantalizing possibilities and frustrating gaps in the evidence. We know that the Baghdad Battery could produce electricity. We know that electricity can be used for electroplating. We know that ancient craftsmen valued gilding highly and would have benefited from safer methods of achieving it. Yet, we cannot definitively connect these facts into a coherent narrative of ancient electrical technology actually being used for this purpose. What we can say is that the goldsmith hypothesis represents one of the most plausible and well-developed explanations for why the Baghdad Battery might have been created. It provides a motive, a mechanism, and a context that makes sense in terms of ancient economics and craft traditions. It explains why the technology might have been developed, why it might have been kept secret, and why it might have been lost when the social conditions that supported it changed. Even if we cannot prove the hypothesis true, we can recognize it as a serious and thoughtful attempt to explain a genuinely puzzling phenomenon. The image of an ancient goldsmith working by lamplight in a cluttered workshop, dipping silver ornaments into mysterious solutions and watching as they emerged, transformed into gold, captures something essential about human creativity and ingenuity. Whether or not this image corresponds to historical reality, it reminds us that our ancestors were problem solvers, innovators, seekers of better methods and superior results. They faced challenges and found solutions, just as we do today, and some of those solutions may have been more sophisticated than we typically assume. The electroplating hypothesis also highlights the interconnection between different domains of ancient knowledge. To electroplate successfully, one would need to understand something about metals and their properties, about liquids and their effects on metals, about the strange phenomena that occur when certain combinations of materials are brought together. This understanding might not have been articulated in theoretical terms, but it would have been real nonetheless, embodied in practical skills and workshop traditions that guided the hands of craftsmen even if they could not explain in words what they were doing or why it worked. The search for evidence continues, driven by the hope that somewhere in the vast and excavated regions of the ancient Near East, artifacts await discovery that will resolve the question one way or another. A workshop site with electroplating equipment, a cache of objects that could only have been gilded electrically, a text describing the technique in terms we can recognize. Any of these finds would transform our understanding of what the ancients knew and could accomplish. Until such evidence emerges, the goldsmith hypothesis remains one possibility among several. Compelling but unproven, a story that might be true but that we cannot yet confirm. The Baghdad Battery, sitting quietly in its display case or storage vault, offers no answers to our questions about ancient electroplating. It presents only its form, its components, its carefully crafted structure, leaving us to wonder what purposes those ancient hands intended when they assembled copper and iron within terracotta shells. The mystery endures, as deep and compelling as it was when Wilhelm König first noticed the unusual configuration of these remarkable objects nearly a century ago. Beyond the workshops of ancient goldsmiths, other theories have emerged to explain why the people of Parthian Mesopotamia might have constructed these peculiar electrical devices. The electroplating hypothesis, while compelling in its practicality, does not exhaust the possibilities. Human beings have always sought ways to heal the body, commune with the divine, and protect sacred objects from decay. In each of these realms, the Baghdad Battery might have found a purpose, serving needs that extended far beyond the decoration of jewelry and ornaments. The use of electricity for medicinal purposes has a surprisingly long history, one that stretches back far earlier than most people realize. Ancient physicians were keen observers of natural phenomena, and they would certainly have noticed the peculiar sensations that electrical current produces when it passes through living tissue. A mild shock creates tingling and numbness. Stronger currents cause muscles to contract involuntarily. These effects, mysterious and seemingly magical to those who did not understand their cause, might well have been interpreted as therapeutic interventions capable of driving out illness or restoring balance to the body. We know with certainty that ancient healers used electric fish for medicinal purposes, a practice documented in texts from multiple civilizations around the Mediterranean and beyond. The torpedo ray, a creature capable of delivering shocks of up to 200 volts, was prescribed by Roman physicians for conditions ranging from headaches to gout. Patients would place the affected body part in contact with the living fish, receiving repeated jolts that were believed to cure or alleviate their ailments. The physician Scribonius Largus, writing in the 1st century of the Common Era, specifically recommended torpedo ray treatments for chronic pain. Ancient doctors were willing to use living creatures as sources of therapeutic electricity. It requires no great leap of imagination to suppose they might have sought artificial means of producing similar effects. A device that could generate a controlled, repeatable electrical sensation would have offered significant advantages over relying on live fish. It could be used anywhere, not just near the sea. It could be stored and transported easily, and it could be applied with greater precision, delivering current to specific locations on the body rather than wherever the fish happened to make contact. The Baghdad Battery, with its modest output of 1 to 2 volts, would have been well suited for such applications. The current produced would be strong enough to create noticeable sensations on the skin, but far too weak to cause injury. A healer could apply the terminals of the device to a patient's body, perhaps at points believed to be centers of vital energy, and allow the gentle flow of current to work its mysterious effects. The tingling sensation might have been interpreted as the movement of healing forces, the departure of evil spirits, or the restoration of proper balance to the bodily humors. This medical interpretation gains additional credibility when we consider the broader context of ancient healing practices. Physicians in the ancient world employed a vast array of treatments that seem strange or even nonsensical by modern standards. Yet many of these practices persisted for centuries because patients believed they worked. Bloodletting, cupping, the application of leeches, the use of toxic substances like mercury and arsenic all found their place in the medical traditions of antiquity. Electrical therapy would fit comfortably within this diverse pharmacopoeia of healing interventions. The connection between electricity and the body has continued to fascinate healers throughout history. In the 18th and 19th centuries, after the development of reliable electrical devices, physicians enthusiastically applied current to treat everything from paralysis to melancholy. Electrotherapy became a respected branch of medicine, with elaborate machines designed to deliver precisely calibrated doses of electrical stimulation. While many of these treatments proved ineffective, some applications of electrical therapy have survived into modern medicine, including the use of electrical stimulation for pain management and the treatment of certain neurological conditions. Some researchers have drawn parallels between the Baghdad Battery and the ancient practice of acupuncture, which originated in China but spread along the trade routes that connected East and West. Traditional acupuncture involves inserting thin needles into specific points on the body, believed to lie along channels of vital energy called meridians. The stimulation of these points is thought to restore proper flow of energy and thereby alleviate illness. Could the Baghdad Battery have been used to enhance acupuncture treatments, adding electrical stimulation to the mechanical effect of the needles? This hypothesis remains highly speculative, as there is no direct evidence linking the artifacts to acupuncture practice. However, the idea is not as far-fetched as it might initially seem. Knowledge of acupuncture could certainly have traveled westward along the Silk Road during the Parthian period, reaching Mesopotamia through the same channels that brought silk and spices and other goods from China. A healer familiar with both traditions might have experimented with combining them, discovering that electrical current enhanced the effects of needle stimulation. Modern electroacupuncture, which applies mild electrical current through acupuncture needles, is a recognized therapeutic technique used by practitioners around the world. Research has shown that electrical stimulation can enhance the release of endorphins and other natural pain-relieving substances, providing a physiological basis for the reported benefits. If ancient healers stumbled upon this technique through trial and error, they might have continued using it without understanding why it worked. Simply observing that patients who received electrical acupuncture seemed to improve more rapidly than those who did not. Beyond medicine, the Baghdad Battery might have served purposes that were more spiritual than practical. Religion permeated every aspect of life in the ancient world, and objects that produced mysterious effects were often incorporated into sacred rituals. A device that could create tingling sensations, cause sparks, or produce other unusual phenomena might have been employed by priests to demonstrate divine power, to induce altered states of consciousness, or to validate the authority of religious institutions. The temples of ancient Mesopotamia were not merely places of worship, but also centers of knowledge and technological expertise. Priests were among the most educated members of society, trained in astronomy, mathematics, medicine, and various practical arts. They had both the intellectual capacity to develop sophisticated devices and the motivation to deploy them in ways that would enhance the prestige of their institutions. A battery that produced seemingly miraculous effects could serve as powerful evidence of divine favor, strengthening the bonds between worshippers and the gods they served. Some scholars have suggested that the Baghdad Battery might have been used to create impressive displays within temple settings. A current passed through a thin wire could cause it to glow red hot, producing light without visible flame. Sparks could be generated by completing and breaking circuits, creating flashes that would seem supernatural to those unfamiliar with the underlying phenomenon. Statues or sacred objects could be electrified, delivering mild shocks to worshippers who touched them and thereby seeming to possess divine life or power. The idea of sacred objects that produced physical sensations was not foreign to ancient religion. Throughout the ancient world, Certain artifacts were believed to carry divine presence, to heal the sick, or to protect the faithful from harm. The Ark of the Covenant, described in the Hebrew Bible, was said to be so powerful that those who touched it improperly would be struck dead. While scholars have offered various explanations for these traditions, some have suggested that the Ark might have functioned as a kind of electrical capacitor, accumulating static charge that could discharge violently when touched. Similar mechanisms might have been deliberately incorporated into sacred objects to reinforce beliefs about divine power. Another intriguing possibility is that the Baghdad Battery was used not for its electrical properties at all, but simply as a container for sacred scrolls or other precious documents. The sealed design of the device, with its watertight bitumen stopper, would have been excellent for protecting papyrus or parchment from moisture and decay. The copper cylinder within might have provided additional protection against insects or other pests that could damage organic materials. Viewed from this perspective, the battery configuration might have been incidental, a byproduct of construction choices made for entirely different reasons. This scroll container hypothesis has the advantage of explaining why the devices might have been found in a religious or scholarly context. Libraries and archives in the ancient world faced constant threats from humidity, vermin, and simple decay. Valuable texts were often stored in sealed jars to protect them from these dangers, and the Baghdad Battery could represent a particularly sophisticated version of such a container. The presence of copper might have been valued for its antimicrobial properties, which ancient people recognized even without understanding the underlying science. Yet, if the devices were merely scroll containers, the question remains why they were constructed with such careful attention to the arrangement of copper and iron. Random storage vessels would not require an iron rod suspended precisely in the center of a copper cylinder. The deliberate design suggests intentionality, a purpose beyond simple storage that required these specific components in this specific configuration. The mystery refuses to resolve itself into a single, simple explanation. Perhaps the truth encompasses multiple purposes, with the same devices serving different functions in different contexts. A battery used for electroplating in a goldsmith's workshop might also have been employed by a healer seeking to treat pain, or by a priest seeking to demonstrate divine power, or by a scribe seeking to protect precious texts. The versatility of the technology could have ensured its spread through various sectors of society, each finding applications suited to their particular needs. The fragmentary nature of our evidence makes it impossible to determine with certainty which of these theories, if any, captures the true purpose of the Baghdad Battery. We have the artifacts themselves, silent witnesses that reveal their construction, but not their function. We have the experimental demonstrations, proving they could generate electricity. And we have a range of plausible applications, each supported by circumstantial evidence, but none definitively confirmed. The mystery invites us to hold multiple possibilities in mind, simultaneously acknowledging the limits of what we can know about the distant past. What all of these alternative theories share is a recognition that the ancient world was more complex and sophisticated than we often assume. Whether the Baghdad Battery was used for medicine or magic or preservation or some combination of purposes, its existence testifies to the ingenuity of ancient craftsmen and the breadth of their practical knowledge. They observed phenomena, experimented with materials, and created devices that served their needs, just as humans have always done throughout our long history on this planet. The search for the true purpose of the Baghdad Battery continues to this day, with researchers approaching the question from multiple angles. Some focus on chemical analysis of residues within surviving artifacts, hoping to identify traces of the electrolytes that were once used. Others examine archaeological contexts, looking for patterns in where and how the devices were deposited that might reveal their function. Still others conduct ever more sophisticated replica experiments, casing the capabilities of the technology under various conditions. Each approach contributes another piece to the puzzle, even if the complete picture remains frustratingly out of reach. In the meantime, the alternative theories remind us that the question of purpose is not merely academic. Understanding what the ancients did with their electricity, if indeed they had it, would tell us something profound about their world and their understanding of nature. It would reveal priorities and preoccupations, beliefs and practices that have otherwise been lost to time. The Baghdad Battery is not just a curious artifact, but a window into a vanished civilization, offering glimpses of lives lived and problems solved by people whose names and faces we will never know. For every researcher who has embraced the battery hypothesis with enthusiasm, there has been another who has regarded it with profound skepticism. The mainstream archaeological community has never fully accepted the idea that the Baghdad artifacts were electrical devices. Their objections deserve careful consideration. These scholars are not close-minded or dismissive of ancient ingenuity. Rather, they applied the same rigorous standards of evidence to this claim that they would apply to any other extraordinary assertion about the past. Their doubts illuminate important questions that proponents of the battery theory have struggled to answer satisfactorily. The most fundamental objection is also the simplest. If the ancients possessed electrical technology, where is the rest of the infrastructure that would have accompanied it? Batteries do not exist in isolation. They are part of systems that include wires, connectors, switches, and devices that utilize the current they produce. Yet, no ancient wires have been discovered in association with the Baghdad artifacts or anywhere else in the archaeological record of Mesopotamia. No connectors or terminals have been identified. Appliances or machines that might have been powered by electrical current have come to light. The batteries, if that is what they are, appear entirely alone. This absence is deeply problematic for the battery hypothesis. Modern experience tells us that electrical technology leaves abundant traces. We find not just batteries, but the entire ecosystem of devices and infrastructure that surrounds them. If the ancients used electricity for electroplating, we would expect to find the tanks and frames and connecting apparatus that such work requires. If they used it for medicine, we would expect to find specialized applicators and treatment devices. If they used it for religious purposes, we would expect to find the mechanisms that created the spectacular effects. Yet none of these supporting artifacts have been identified. Proponents of the battery theory have offered various explanations for this absence. Perhaps the connecting wires were made of organic materials that have decayed without trace over the millennia. Perhaps the associated equipment was made of common materials that archaeologists have failed to recognize for what they were. Perhaps the technology was so rare and specialized that very few complete systems ever existed, reducing the chances of any surviving to be discovered. Each of these explanations is possible, but none can be verified. And together they begin to sound like special pleading designed to protect a favorite hypothesis from disconfirming evidence. The skeptics also point out that the battery interpretation rests heavily on the assumption that the ancients would have recognized and exploited the electrical potential of their creation, but this assumption may not be warranted. The generation of electricity requires specific conditions, including the presence of an appropriate electrolyte and a complete circuit connecting the electrodes. There is no evidence that the jars were ever filled with acidic liquid or that the copper and iron components were ever connected externally. Without these elements, the devices would have produced no electrical effect whatsoever, regardless of their theoretical potential. Consider an analogy from everyday experience. A length of copper pipe and an iron nail, placed near each other on a shelf, have the theoretical potential to form a galvanic cell if immersed in electrolyte and connected properly. But no one would claim that such items constitute a battery simply because they could be assembled into one. The same logic applies to the Baghdad artifacts. The fact that they could function as batteries does not prove that they were designed or used as batteries. The resemblance might be entirely coincidental, a chance arrangement of materials that happens to mirror a configuration we recognize from modern technology. The original archaeological context of the artifacts provides little help in resolving the question. The jars were discovered during railway construction rather than systematic excavation, and the precise circumstances of their burial were not carefully documented. We do not know whether they were found together or scattered across the site, whether they were associated with a workshop or a temple or a dwelling, whether they were deliberately buried or simply discarded. All of these details might have provided crucial clues about their function, but they were lost in the haste of the original discovery. Some archaeologists have proposed that the objects were not batteries at all, but simply storage vessels for sacred scrolls or other precious items. The sealed design would have protected contents from moisture, insects, and decay. The copper cylinder might have been valued for preserving whatever was placed inside, as copper has natural antimicrobial properties that ancient people observed even without understanding the underlying chemistry. The iron rod might have served as a handle or support for rolled documents. Viewed from this perspective, the battery-like configuration is merely incidental, a byproduct of practical design choices made for entirely different purposes. This storage vessel hypothesis has the advantage of requiring no extraordinary assumptions about ancient knowledge. Sealed containers for protecting valuable items were common throughout the ancient world, and variations in their design are to be expected. The presence of metal components within a ceramic vessel is unusual, but not unprecedented. If we did not live in an age of batteries and electrical devices, we might never have thought to interpret these objects as anything other than specialized containers. Our modern perspective shapes what we see, and this shaping can lead us astray as easily as it can illuminate. The skeptics also questioned the electroplating theory that many battery proponents have embraced. While experiments have shown that replica batteries can deposit thin layers of metal through electrolysis, no ancient artifacts have been definitively identified as products of this process. The gilded objects from Mesopotamia that some researchers cite as evidence can equally well be explained by fire gilding or other non-electrical techniques that were certainly known and practiced in the ancient world, without a clear example of an electroplated artifact. The practical application of the supposed batteries remains undemonstrated. Furthermore, electroplating, as practiced with Baghdad Battery replicas, is an extremely slow and inefficient process. The low voltage and current produced by these devices means that depositing even a thin layer of gold would require many hours or even days of continuous operation. Ancient craftsmen, who were practical people concerned with producing results in reasonable time frames, would have found fire gilding far more efficient for most purposes. The supposed advantage of electroplating, that it avoids the toxic mercury fumes of fire gilding, might not have seemed worth the enormous additional time required. The medical and religious applications proposed for the batteries face similar evidential challenges. While it is true that ancient physicians used electric fish for therapeutic purposes, there is no textual or archaeological evidence that artificial electrical devices were ever employed in healing. The extensive medical literature that survives from the ancient Near East, including detailed descriptions of treatments and procedures, makes no mention of anything resembling electrical therapy. If such treatments existed, their absence from the written record requires explanation. Similarly, the suggestion that batteries were used to create impressive effects in temple settings remains purely speculative. No ancient sources describe such phenomena, and no physical evidence of electrical installations has been found in any excavated temple. The assumption that priests would have employed technological trickery to awe their congregations may also reflect modern cynicism more than ancient reality. Many priests were sincere believers in the gods they served, and the suggestion that they routinely deceived their followers projects contemporary attitudes onto people who lived in very different circumstances. Some skeptics have suggested that the Baghdad Battery represents a case of patternicity, the human tendency to perceive meaningful patterns where none exist. Our brains are wired to recognize familiar shapes and configurations, and this ability sometimes leads us astray. A person familiar with batteries will naturally notice when a collection of objects resembles a battery. Just as a person familiar with faces will see faces in clouds and rock formations. The recognition feels significant, but it may tell us more about our own minds than about the objects we are observing. The principle of parsimony, often called Occam's razor, suggests that we should prefer simpler explanations over more complex ones when both account equally well for the evidence. The storage vessel hypothesis requires only that ancient craftsmen made a sealed container with metal components, something well within their documented capabilities. The battery hypothesis requires that they understood electrochemistry, developed applications for electrical current, built supporting infrastructure that has entirely vanished, and kept the entire enterprise out of the written record. The latter explanation, while more exciting, demands far more unsupported assumptions. Yet, the skeptical position is not without its own weaknesses. The careful construction of the Baghdad artifacts, with the iron rod precisely centered, remains difficult to explain if the electrical configuration was merely accidental. Random variation in container design would not consistently produce this specific arrangement. Something about the configuration mattered to the makers, even if we cannot determine what that something was. The skeptics have been better at poking holes in the battery hypothesis than at offering a compelling alternative explanation for the artifact's unusual design. The debate over the Baghdad Battery reflects a broader tension in archaeology between romantic and rigorous approaches to the past. The romantic approach delights in mysteries and marvels, finding evidence of lost knowledge and forgotten capabilities wherever possible. The rigorous approach demands solid evidence for extraordinary claims, preferring mundane explanations that fit comfortably within established understanding. Both approaches have value, and the truth often lies somewhere between them. The romanticism reminds us that the past was full of surprises and that our ancestors were capable of things we might not expect. The rigor prevents us from believing whatever we find most appealing, grounding our understanding in evidence rather than wishful thinking. The mainstream archaeological consensus currently leans toward skepticism about the battery hypothesis, though this consensus is not unanimous. Most scholars who have examined the question conclude that while the devices could theoretically function as batteries, there is insufficient evidence that they were designed or used for that purpose. It's the absence of supporting infrastructure, the lack of textual references, and the availability of alternative explanations all weigh against the electrical interpretation. The Baghdad Battery remains an intriguing curiosity. To boot, it has not achieved acceptance as a genuine example of ancient electrical technology. This skepticism does not mean the case is closed. New evidence could emerge at any time that would shift the balance of probability. The discovery of ancient wires or connectors, or of artifacts that could only have been produced through electrolysis, or of texts describing electrical phenomena, would dramatically strengthen the battery hypothesis. Archaeology is a discipline where established understanding can be overturned by a single significant find. And the history of the field is full of examples where initially dismissed theories were later vindicated by new discoveries. In the meantime, the Baghdad Battery serves as a valuable reminder of how difficult it is to interpret the material remains of vanished cultures. We look at ancient objects through the lens of our own experience, and that lens shapes what we see in ways we do not always recognize. The same artifact can appear as a revolutionary technology to one observer and as an ordinary container to another, depending on their background, their assumptions, and their willingness to entertain unconventional possibilities. The truth about the Baghdad Battery, whatever it may be, lies buried not only in the sands of Iraq, but also in the complexities of human perception and interpretation. The skeptical perspective, for all its caution, does not diminish the genuine mystery that the artifacts represent. Even if they were not batteries, the Baghdad jars remain objects of considerable interest, evidence of sophisticated craftsmanship and deliberate design. Something motivated their creation, and understanding what that something was would teach us about the people who made them and the world in which they lived. The question of what the ancient craftsmen intended may never be answered with certainty, but the asking of it connects us to them across the vast distances of time, joining our curiosity to theirs in an unbroken chain of human wondering. The Baghdad Battery, whatever its true nature, belongs to a broader category of ancient achievements that challenge our assumptions about the steady march of human progress. We tend to imagine history as a rising line, with each generation building upon the accomplishments of those who came before, climbing ever upward toward greater knowledge and capability. Yet, the archaeological record tells a different story, one filled with peaks and valleys, with remarkable discoveries that flourished for a time and then vanished without trace. The ancients knew things that we have forgotten, mastered techniques that we struggle to replicate, created wonders that we can barely comprehend. Perhaps the most famous example of lost ancient technology is the Antikythera mechanism, a device so sophisticated that its discovery forced historians to completely revise their understanding of what ancient craftsmen could achieve. The mechanism was recovered in 1900 from a shipwreck off the coast of a small Greek island, crusted with marine growth and corroded almost beyond recognition. For decades, it sat in a museum, dismissed as an interesting but unremarkable lump of bronze. Only when modern imaging technology was applied to its interior did the true nature of this extraordinary object become apparent. The Antikythera mechanism was an analog computer, precision instrument containing at least 30 interlocking bronze gears that could predict astronomical events with remarkable accuracy. By turning a hand crank, the user could calculate the positions of the sun and moon, predict lunar and solar eclipses, and track the cycles of the ancient Olympic Games. The device incorporated a differential gear, a component that was not reinvented until the 16th century of the Common Era. Its smallest gears had teeth measuring just 1.5 millimeters across, requiring a level of metalworking precision that seems almost impossible for the ancient world. Nothing else like the Antikythera mechanism has ever been found. We have no workshop remains, no preliminary prototypes, no simpler devices that might have led to its development. It appears fully formed in the archaeological record, like a visitation from another time, and then disappears entirely. The knowledge required to build such a device, knowledge of astronomy and mathematics and precision metalworking, must have existed in some form, must have been taught and learned and refined over generations. Yet all of that accumulated expertise vanished so completely that we would never have known it existed had this single artifact not been lost at sea and preserved by accident. The parallel to the Baghdad Battery is striking. Both objects represent capabilities that we did not expect the ancients to possess. Both appear without clear antecedents or successors in the archaeological record. Both challenge the comfortable narrative of continuous progress that underlies much of our thinking about history. And both remind us that the past is far more complex and mysterious than the simplified stories we tell ourselves would suggest. Greek fire presents another haunting example of lost knowledge. A weapon so devastating that it helped preserve the Byzantine Empire for centuries, yet so secret that its exact composition remains unknown to this day. This incendiary substance could be projected from ships onto enemy vessels, where it would burn fiercely, even on water. Attempts to extinguish it only seemed to spread the flames more widely. Opposing fleets learned to fear the roar of the siphons and the terrifying sight of liquid fire arcing across the waves toward their wooden hulls. The Byzantines guarded the secret of Greek fire with extraordinary care, restricting knowledge of its manufacture to a small circle of trusted craftsmen. Emperors swore solemn oaths to never reveal the formula to outsiders, and the penalty for divulging the secret was death. This obsessive secrecy succeeded in keeping the weapon out of enemy hands, but it also ensured that when the Byzantine Empire finally fell, the knowledge fell with it. Modern chemists have proposed various formulas that might replicate some properties of Greek fire, but none can claim with certainty to have rediscovered the original composition. The loss of Greek fire illustrates one of the primary mechanisms by which ancient knowledge disappears. When expertise is concentrated in a small number of hands and transmitted only through personal instruction, it becomes vulnerable to disruption. A war, a plague, an economic collapse. Any catastrophe that breaks the chain of transmission can erase centuries of accumulated learning in a single generation. The craftsmen who knew the secrets die, and their knowledge dies with them, leaving only legends and artifacts behind. Damascus steel represents yet another tantalizing example of lost metallurgical knowledge. For centuries, swordsmiths in the Islamic world produced blades of legendary quality, weapons that could hold an edge sharp enough to slice a falling silk scarf and flexible enough to bend without breaking. The surface of these blades displayed distinctive watered patterns, swirling bands of light and dark that marked them as products of a special and mysterious process. Warriors prized Damascus swords above all others, and poets sang of their almost supernatural properties. The technique for producing true Damascus steel was lost sometime in the 18th century, and despite intensive efforts by modern metallurgists, it has never been fully recovered. We now understand that the patterns resulted from the presence of carbon nanotubes and cementite nanowires within the steel, structures that formed during a specific and still poorly understood process of forging and heat treatment. The original smiths would not have known these terms or understood the underlying science, yet through generations of empirical experimentation, they discovered methods that produce these extraordinary microstructures. Recent research has made progress in replicating some characteristics of Damascus steel, but the exact techniques used by the ancient and medieval smiths remain elusive. The knowledge was passed from master to apprentice through demonstration and practice, never written down in detail, never codified in forms that could survive the disruption of the tradition. When the chain of transmission broke, probably due to changes in the supply of raw materials from particular Indian mines, the ability to produce true Damascus steel was lost to humanity. Roman concrete offers a somewhat happier story, a case where lost knowledge has been substantially recovered through modern scientific investigation. The Romans built structures of concrete that have stood for 2,000 years, including the Dome of the Pantheon, which remains the largest unreinforced concrete dome in the world. Medieval and early modern builders, lacking the Roman formula, produced inferior concrete that crumbled within decades. Only in recent years have scientists begun to understand what made Roman concrete so remarkably durable. The secret, it turns out, lay in the incorporation of volcanic ash, specifically a type found near the town of Pozzuoli in southern Italy, when mixed with lime and seawater. Triggered chemical reactions that produced aluminum tobermorite crystals within the concrete matrix. These crystals actually grew stronger over time as seawater penetrated the material, transforming what would have been damaging infiltration into a source of increased durability. The Roman engineers did not understand the chemistry, but they observed that concrete made with pozzolan ash lasted longer than other mixtures, and they exploited this discovery throughout their empire. The recovery of Roman concrete knowledge demonstrates that lost techniques can sometimes be rediscovered through careful scientific analysis of surviving artifacts. By studying the chemical composition and microstructure of ancient materials, modern researchers can reverse engineer the processes that created them. This approach has been applied to many ancient technologies, from Egyptian blue pigment to Chinese bronze casting to Mayan plaster. Each successful reconstruction adds to our understanding of what the ancients could achieve and how they achieved it. Yet for every technique we have managed to recover, many others remain mysterious. We do not know how the Egyptians moved and positioned the massive stones of the pyramids with such precision. We do not know how the Nazca people created their enormous geoglyphs visible only from the air. We do not know how the inhabitants of Easter Island transported their monumental statues across miles of rough terrain. In each case, modern researchers have proposed theories and conducted experiments, but definitive answers remain elusive. The ancients took their secrets to their graves, leaving us to puzzle over their accomplishments. The Baghdad Battery fits naturally into this gallery of ancient mysteries. This collection of artifacts and achievements that exceed our expectations for their time. Whether or not it was truly an electrical device, it represents a level of sophisticated craftsmanship that demands explanation. The careful arrangement of materials, the precision of construction, the deliberate design choices all speak to knowledge and skill that we have difficulty fully appreciating. Something was being attempted, something was being achieved, and understanding what that something was would illuminate a corner of the past that currently remains dark. The broader pattern that emerges from these examples is one of technological knowledge as fragile and impermanent, subject to loss through social disruption, inadequate transmission, or simple forgetting. We imagine that once something is discovered, it stays discovered forever, that knowledge accumulates like sediment, building up layer upon layer. But the historical record suggests otherwise. Discoveries can be lost. Skills can be forgotten. Tired traditions of expertise can vanish within a generation if the conditions that sustain them change sufficiently. This fragility has profound implications for how we understand our relationship to the past. We are not necessarily the most knowledgeable or capable people who have ever lived. In some domains, our ancestors achieved things we cannot match. They knew things we do not know. They could do things we cannot do. It's the assumption of steady progress, of our inevitable superiority to those who came before, is not supported by the evidence. We stand not at the summit of an ascending slope, but on one peak among many in a complex landscape of human achievement. The mechanisms of knowledge loss are multiple and overlapping. Secrecy, as with Greek fire, can preserve knowledge in the short term, but makes it vulnerable to catastrophic loss. Oral transmission, as with Damascus steel, depends on unbroken chains of teacher and student that can be severed by war or plague or economic change. Even written records, as the burning of the Library of Alexandria demonstrates, can be destroyed in moments of violence or neglect. Knowledge requires active maintenance, continuous renewal, deliberate effort to preserve and transmit. While that effort, it fades like footprints in sand. The modern age, with its emphasis on publication and documentation, might seem to offer better prospects for preserving knowledge against future loss. Our libraries and databases contain more information than any previous civilization could have imagined. Yet we too are vulnerable in ways we do not always recognize. Much of our most important knowledge exists in digital forms that depend on functioning technology and stable infrastructure. A sufficiently severe disruption could render vast stores of information inaccessible, unreadable, effectively lost, even though the physical media might survive. The story of the Baghdad Battery, whatever its ultimate resolution, reminds us of the depth and complexity of the human past. We look back across thousands of years and see only fragments, surviving remnants of civilizations that were once as vibrant and complex as our own. We try to reconstruct their achievements from broken pottery and corroded metal, from partial texts and ambiguous images. We fill in the gaps with our best guesses, knowing that our guesses may be wrong, that the truth may be stranger than anything we have imagined. In this light, the little clay jars from Khujut Rabu become something more than mere curiosities or topics for academic debate. They become symbols of all that we have lost, all that we do not know, all that we may never recover. They remind us that the past holds surprises we have not yet discovered, secrets we have not yet penetrated, achievements we have not yet recognized. They invite humility about our own position in history and curiosity about what still lies buried, waiting to be found. The ancients were not primitive versions of ourselves, stumbling through darkness toward the light we now enjoy. They were full human beings, as intelligent and creative as any who have lived, facing their own challenges with their own solutions. Some of those solutions were brilliant, elegant, effective beyond anything we might have expected. Some were lost, erased by time and circumstance, leaving only tantalizing hints of what once existed. The Baghdad Battery, true electrical device, or elaborate storage vessel, stands as witness to that lost brilliance, a messenger from a world we can glimpse, but never fully know. The question of what the Baghdad Battery could actually do has never been left to speculation alone. From the earliest days following Wilhelm König's provocative hypothesis, researchers have built replicas and tested them under controlled conditions, seeking to establish the boundaries of what was physically possible with such devices. These experiments have spanned decades and continents, conducted by scientists, engineers, hobbyists, and documentary filmmakers, each adding another data point to our understanding of this ancient enigma. The accumulated results paint a picture of a technology that was genuinely functional, if limited in its capabilities. The tradition of replica experimentation began with Willard Gray in 1940 and has continued without interruption to the present day. Each generation of researchers has brought new tools and new questions to the investigation, refining our understanding of the variables that affect the battery's performance: the choice of electrolyte, the purity of the metals, the temperature of the solution, the surface area of the electrodes. All of these factors influence how much current the device produces and how long it can sustain that output. Through systematic variation of these parameters, experimenters have mapped the performance envelope of the Baghdad Battery with considerable precision. The voltage produced by a single cell consistently falls in the range of 1 to 2 volts, regardless of the specific electrolyte used. This remarkable consistency reflects the underlying electrochemistry, which depends primarily on the difference in reactivity between copper and iron, rather than on the particular acid that facilitates the reaction. Vinegar produces roughly the same voltage as grape juice, which produces roughly the same voltage as lemon juice or dilute sulfuric acid. The voltage is determined by the metals, while the electrolyte affects mainly the current and the longevity of the reaction. Current output is more variable, depending strongly on the concentration and conductivity of the electrolyte solution. Strong acids produce higher currents than weak ones, and solutions with more dissolved ions conduct electricity more readily than pure liquids. Typical replica batteries generate currents measured in milliamperes, enough to produce measurable effects, but far below the amperage that powers modern devices. How Baghdad Battery could not light an incandescent bulb or run an electric motor, but it could drive slow electrochemical processes or create subtle physiological sensations. One of the most ambitious series of experiments was conducted by Arne Eggebrecht, a German researcher who dedicated years to exploring the electroplating hypothesis. Eggebrecht constructed multiple replica batteries and used them to deposit thin layers of gold onto silver figurines, documenting the process with meticulous care. His experiments demonstrated that electroplating was indeed possible with these devices, though it required patience and persistence. Building up a visible layer of gold took many hours of continuous operation, with periodic replacement of the electrolyte as it became depleted. Eggebrecht's work was featured in numerous documentaries and publications, bringing the Baghdad Battery to a wider audience than it had ever reached before. His gilded figurines became iconic images, tangible demonstrations of what the ancient technology might have achieved. Critics noted that his experiments proved only that electroplating was possible, not that the ancients actually practiced it. But the visual impact of the gold-covered objects was undeniable. Here was something that could be seen and touched, a bridge between the speculative and the concrete. The television documentary Mythbusters devoted an episode to the Baghdad Battery in 2005, applying their signature blend of enthusiasm and skepticism to the ancient mystery. The team constructed 10 replica batteries and connected them in series, generating approximately 4 volts of combined output. They then used this power to electroplate a small coin with a thin layer of zinc, successfully demonstrating the principle, if not the specific application, that proponents had proposed. The experiment was entertaining and educational, introducing millions of viewers to a mystery many had never heard of. More rigorous scientific investigations have been conducted at universities and research institutions around the world. 2002, team at Smith College in Massachusetts performed detailed analyses of replica battery performance under various conditions, publishing their results in peer-reviewed journals. Their work confirmed earlier findings about voltage and current ranges while providing more precise measurements in better controlled conditions. They also explored the degradation of performance over time, documenting how the batteries weakened as the iron electrodes corroded and the electrolyte solutions became contaminated with reaction products. The Smith College researchers found that optimal performance required careful attention to the cleanliness of the metal surfaces and the freshness of the electrolyte. A newly assembled battery with clean electrodes and fresh acid solution would produce its highest output immediately, then gradually decline as chemical changes accumulated. Maintaining steady performance would have required periodic maintenance, cleaning the electrodes and replacing the liquid. This finding has implications for how the ancients might have used such devices, suggesting that applications requiring sustained output would have demanded ongoing attention and care. Computer modeling has complemented physical experimentation, allowing researchers to simulate the behavior of Baghdad battery configurations without building and testing every variation. These models incorporate the known electrochemistry of copper-iron galvanic cells and predict how changes in design parameters would affect performance. While models cannot replace physical testing, they can guide experimentation by identifying promising avenues for investigation and explaining observed results in terms of underlying physical principles. Some researchers have explored whether connecting multiple cells in more sophisticated configurations could have enhanced the capabilities of the technology. Batteries can be connected in series to increase voltage, with each additional cell adding its output to the total. They can also be connected in parallel to increase current while maintaining the same voltage. Ancient craftsmen who understood these principles could have built power supplies capable of effects beyond what a single cell could achieve. 10 cells in series would produce 10 to 20 volts, enough to create noticeable sparks or drive more rapid electrochemical processes. The question of whether the ancients understood such configurations remains open. No multi-cell arrangements have been discovered archaeologically, and the surviving Baghdad artifacts appear to be individual units rather than components of larger systems. Yet the absence of evidence is not evidence of absence, and it is possible that more complex arrangements existed but have not survived or have not been recognized for what they were. The fragmentary nature of the archaeological record leaves ample room for undiscovered possibilities. Documentary filmmakers have continued to find the Baghdad Battery an irresistible subject, producing programs that range from sober scientific investigation to breathless speculation about ancient mysteries. The topic fits naturally into the genre of alternative history, appealing to viewers who enjoy contemplating possibilities that mainstream scholarship has rejected or ignored. These programs vary widely in quality and accuracy, with some presenting balanced assessments of the evidence and others veering into sensationalism. Their collective effect has been to keep the Baghdad Battery in public consciousness, ensuring that each new generation encounters this intriguing puzzle. The internet age has democratized experimentation, allowing hobbyists and amateur scientists to build and test their own replica batteries and share their results with a global audience. YouTube posts dozens of videos showing homemade Baghdad batteries in action, their creators demonstrating voltage measurements and simple electroplating experiments. These grassroots efforts lack the rigor of professional research, but contribute to a broader culture of curiosity and hands-on investigation. They also provide a steady stream of informal verification that the basic battery hypothesis is physically sound. Educational institutions have incorporated Baghdad battery replicas into science curricula, using them to teach principles of electrochemistry in a context that captures student interest. Building a working battery from simple materials connects abstract concepts to tangible experience, making the science more accessible and memorable. The historical mystery provides additional motivation, encouraging students to think about how scientific understanding develops and how much remains unknown about the past. Teachers report that the Baghdad Battery unit consistently generates enthusiasm and engagement. The ongoing scientific conversation about the Baghdad Battery has evolved over the decades, reflecting changing standards of evidence and interpretation in archaeology and history of science. Early discussions focused primarily on whether the devices could function as batteries, a question that has been definitively answered in the affirmative. More recent debates center on whether they were actually used as batteries, a question that may never be resolved without new archaeological discoveries. The distinction between could and did remains the crux of the controversy. Some researchers have called for renewed archaeological investigation at the original discovery site and other locations in the region that might yield additional artifacts or contextual information. Modern excavation techniques are far more sophisticated than those available in the 1930s, capable of recovering and analyzing evidence that earlier diggers would have missed or destroyed. Unfortunately, the political instability that has plagued Iraq for decades has made systematic archaeological work extremely difficult. The very ground that might hold answers to our questions remains largely inaccessible to scientific investigation. Chemical analysis of the original artifacts could potentially provide crucial evidence about how they were used. Residues of ancient electrolytes might still cling to the interior surfaces, identifiable through modern spectroscopic techniques. Traces of metals deposited through electroplating might be detectable on associated objects, where patterns and corrosion signatures might reveal whether the devices were used repeatedly or only occasionally. Such analyses have been proposed, but not yet conducted, partly due to the dispersal and damage of the artifacts, and partly due to the challenges of access and permission. The replica experiments have also raised new questions that earlier investigators did not consider. What would happen if multiple batteries were connected to work together? How would different electrogeometries affect performance? Could alternative metals available in antiquity produce different results? Each answered question generates new ones, expanding the frontier of investigation rather than closing it down. The Baghdad Battery has proven to be not a single puzzle, but a family of related puzzles, each illuminating different aspects of the central mystery. The scientific community remains divided on the significance of the Baghdad Battery, with opinions ranging from enthusiastic acceptance to dismissive skepticism. What unites researchers across this spectrum is a recognition that the artifacts are genuinely unusual and deserve serious attention. The easy dismissals that characterized some early responses have given way to more nuanced assessments that acknowledge both the reality of the battery function and the uncertainty about ancient intentions. The conversation continues, informed by new experiments and new evidence, never quite reaching resolution. Perhaps the most important contribution of the replica experiments has been to establish a firm foundation of physical fact beneath the speculation and controversy. Whatever the ancients intended, we now know with certainty what their devices could do. We know the voltage ranges and current outputs. We know which electrolytes work and which do not. We know the limitations imposed by the basic electrochemistry of copper and iron. This knowledge constrains our theorizing, ruling out applications that would have required capabilities beyond what the technology could provide, while confirming the feasibility of those within its reach. The accumulated weight of experimental evidence has shifted the Baghdad Battery from the realm of pure speculation into the domain of established possibility. The devices work. They produce electricity. They can drive electrochemical processes. These facts are no longer in dispute. What remains uncertain is whether the ancients recognized and exploited these capabilities, whether the electrical function was intentional or incidental, whether the batteries represent a lost tradition of ancient electrical technology or merely a curious configuration of materials that happens to resemble modern devices? These questions await answers that only future discoveries can provide. In laboratories, in classrooms, in documentary studios, in internet forums, the investigation continues. Each new experiment adds another piece to the puzzle, another constraint on possible interpretations, another confirmation of what is physically achievable with ancient materials and methods. The Baghdad Battery has become a touchstone for questions about ancient technology and lost knowledge, a concrete example around which broader debates about human history can organize themselves. The little clay jars from Khujut Rabu have traveled far from their desert origins, becoming objects of global fascination and ongoing inquiry. The story of the Baghdad Battery took a tragic turn in the spring of 2003, when war came once again to the ancient land between the rivers. As coalition forces advanced on the Iraqi capital, the institutions that had preserved the country's cultural heritage for generations found themselves suddenly vulnerable. The National Museum of Iraq, where Wilhelm König had first examined the mysterious jars nearly 7 decades earlier, stood in the path of conflict, its treasures unprotected against the chaos that was about to engulf the city. In the days following the fall of Baghdad, looters descended upon the museum in waves, smashing display cases and carrying off whatever they could seize. The world watched in horror as images emerged of ransacked galleries and shattered artifacts. The accumulated legacy of millennia scattered and destroyed in hours. Among the objects that vanished during those terrible days were items from the Baghdad Battery collection, swept away into the murky networks of the international antiquities trade, or simply lost in the confusion. The precise fate of the original artifacts remains uncertain to this day. The looting of the National Museum represented one of the greatest cultural catastrophes of modern times, a wound to human heritage that can never be fully healed. Estimates of the losses varied widely in the immediate aftermath, with some reports claiming that nearly all of the museum's holdings had been stolen or destroyed. Later, assessments revised these figures downward, as objects that had been hidden by staff or moved to secure locations were gradually accounted for. Yet thousands of items remained missing, including pieces that had formed the foundation of our understanding of ancient Mesopotamian civilization. Some of the Baghdad Battery artifacts were reportedly among those that museum staff managed to protect before the worst of the looting began. Aware that conflict was approaching, curators had quietly moved the most significant objects to secure storage, hiding them in vaults and basements where they might survive the violence to come. These preservation efforts, conducted under conditions of extreme danger and uncertainty, represented acts of extraordinary courage and dedication. The men and women who risked their lives to save these treasures deserve recognition as heroes of cultural preservation. In the years following the war, international efforts to recover looted antiquities achieved partial success. Some objects were traced to dealers and collectors and returned to Iraq. Others were intercepted at borders as smugglers attempted to move them to markets in Europe and America. Interpol and customs agencies around the world cooperated in tracking down stolen pieces, driven by the recognition that these artifacts belonged not just to Iraq, but to all of humanity. Yet many items remained unrecovered, absorbed into private collections, or destroyed by those who could not sell them. The status of the Baghdad Battery artifacts today remains somewhat unclear. Various sources report that at least some of the original objects survived the looting and remain in the National Museum's collection, though they are not currently on public display. Others may be in storage facilities or in the possession of institutions that received them before the war. The fragmentation of the collection makes comprehensive study difficult, as researchers must piece together information from multiple sources and cannot be certain they are working with the same objects that König examined in the 1930s. This uncertainty adds another layer of mystery to an already enigmatic subject. The physical evidence that might resolve debates about the Baghdad Battery's true nature has been compromised by the very forces of conflict and destruction that have plagued the region throughout recorded history. Just as ancient libraries burned and ancient cities fell, so too the modern institutions charged with preserving the past have proven vulnerable to the recurrent storms of human violence. The cycle continues, each generation losing pieces of the heritage that previous generations struggled to preserve. Yet the idea of the Baghdad Battery has proven more durable than the physical artifacts themselves. It's the hypothesis that König proposed, the experiments that researchers conducted, the debates that scholars engaged in. All of these have been documented and disseminated far beyond the walls of any single museum. Even if every original artifact were lost tomorrow, the knowledge we have gained from studying them would survive in books and journals and digital archives. The mystery would endure, inviting future generations to puzzle over the same questions that have fascinated us. There is something deeply moving about the persistence of human curiosity across the ages. The ancient craftsmen who assembled copper and iron within clay vessels were driven by the same impulse to understand and manipulate the natural world that motivates scientists today. They observed phenomena, formed hypotheses, conducted experiments, refined their techniques through trial and error. They may not have possessed our theoretical frameworks or our sophisticated instruments, but they shared our fundamental desire to make sense of the world and to bend it to human purposes. The Baghdad Battery, whether it was truly an electrical device or merely an unusual container, stands as a testament to that enduring curiosity. It represents human beings grappling with the properties of matter, exploring combinations of materials, seeking to achieve effects that served their needs or satisfied their wonder. The specific intentions of those ancient craftsmen may be lost to us forever, but their spirit of investigation reaches across the millennia to touch our own. We recognize in them something essentially human, something that connects us despite all the differences of culture and context that separate our worlds. The limits of what we can know about the past are real and must be acknowledged honestly. We'll probably never know with certainty whether the Baghdad Battery was used for electroplating, pottery, or medicine, or religious rituals, or something else entirely. We'll probably never know the names of the craftsmen who made these objects or the circumstances that led to their creation. We will probably never find the missing pieces of the puzzle that would allow us to reconstruct the full story of ancient electricity, if such a story exists to be told. Some mysteries resist solution, and wisdom lies in accepting that reality rather than forcing false certainties. Yet the uncertainty itself has value. It keeps us humble about our understanding of history, reminding us that the past is not simply a simpler version of the present, but a genuinely foreign country with its own ways of knowing and doing. It invites us to question our assumptions, to consider possibilities we might otherwise dismiss, to remain open to evidence that challenges our expectations. The Baghdad Battery, precisely because it cannot be definitively explained, serves as a permanent reminder of how much we do not, and perhaps cannot know. The philosophical implications extend beyond the specific case of ancient electricity to touch upon broader questions about human knowledge and its limitations. How much has been lost in the vast stretches of unrecorded time before writing was invented? How many discoveries were made and forgotten in the long millennia of prehistory? How many techniques and traditions vanished without trace when the cultures that developed them declined or were conquered? We glimpse only fragments of the full human story, and those fragments may not be representative of the whole. These reflections need not lead to despair or to the abandonment of historical inquiry. On the contrary, they should inspire us to pursue such inquiry with greater vigor and greater humility. Every artifact recovered, every text translated, every site excavated adds another piece to our incomplete picture of the past. The work of archaeologists and historians is genuinely heroic, a collective effort to rescue human memory from the oblivion that constantly threatens to swallow it. The Baghdad Battery is one small part of that rescued memory, one fragment saved from the darkness. As you rest in the stillness of this moment, consider the journey these objects have taken through time, fashioned by hands that turned to dust 2,000 years ago, buried in earth that witnessed the rise and fall of empires, discovered by chance during the construction of a railway, examined by scholars who puzzled over their meaning, attested by scientists who proved they could generate electricity, threatened by war and looting, and finally arriving here in this account, in your awareness. The path from ancient workshop to modern consciousness is long and improbable, yet here we are, connected across the ages by these humble clay vessels. The night outside your window holds countless secrets, just as the sands of Iraq hold artifacts yet undiscovered. Somewhere beneath the surface, objects wait that would transform our understanding of the past, if only we could find them. Somewhere in the unexcavated layers of ancient cities, evidence lies buried that would answer questions we do not yet know to ask. The Baghdad Battery was found by accident, and other finds equally significant might emerge at any moment, in any place where human beings once lived and worked and wondered. The ancient world was vast and complex, filled with people as intelligent and creative as any who have lived. They built monuments that still inspire awe, created artworks of transcendent beauty, developed systems of writing and mathematics and astronomy that lay foundations for all that followed. Among their many achievements, some have been preserved and some have been lost. The Baghdad Battery hints at knowledge that may have existed and vanished, capabilities that may have flourished and faded, traditions that may have burned brightly for a time before guttering out in the winds of historical change. We are the inheritors of all that they preserved and all that they lost. Our civilization rests upon foundations they laid, uses tools they invented, speaks languages that evolved from tongues they spoke. The connection between their world and ours is not merely metaphorical, but real, a chain of transmission stretching back through countless generations of teachers and students, parents and children, masters and apprentices. When we contemplate the Baghdad Battery, we contemplate our own origins, the long, slow accumulation of knowledge and skill that made our world possible. Let the mystery rest gently in your mind as sleep approaches. There is no need to solve it, no requirement to reach a final verdict on what the ancient craftsman intended. The uncertainty can coexist with peace. The questions can remain open without causing distress. Not everything must be known. Not every puzzle must be completed. Some mysteries are meant to be lived with, contemplated, returned to again and again across the years. The Baghdad Battery is such a mystery, a companion for the curious mind, a reminder of the depths of time and the limits of understanding. The stars that shine above you tonight are the same stars that shone above ancient Mesopotamia, the same lights that guided travelers along the Silk Road and illuminated the workshops where unknown artisans assembled copper and iron within clay jars. The universe is old beyond comprehension, and human history occupies only the thinnest sliver of that immensity. Yet, within that sliver, extraordinary things have happened. Minds have awakened, cultures have flourished, knowledge has accumulated and dispersed and accumulated again. The Baghdad Battery is one small node in that vast web of human achievement, one point of light in the constellation of our collective memory. Rest now with the knowledge that the mystery endures, that questions remain to be asked, that the past still holds surprises for those willing to seek them. The ancient craftsmen did their work and passed from the world, leaving behind these enigmatic objects to puzzle future generations. We have received their legacy and pondered it as best we can. Someday, others will take up the inquiry where we leave off, bringing new tools and new perspectives to bear on old questions. The conversation continues across the centuries. An endless dialogue between present and past, between the known and the unknown, between the light of understanding and the darkness that surrounds it. The Baghdad Battery waits in silence, keeping its secrets as it has kept them for 2,000 years. Perhaps those secrets will one day be revealed. Perhaps they will remain forever hidden. Either way, the mystery has enriched our understanding of what it means to be human, to wonder, to seek, to create. That is gift enough from those ancient hands to ours, a treasure more valuable than any that war can destroy or time can erase. Carry it with you into sleep. And let it illuminate your dreams with visions of all that was and all that might have been in the unfathomable depths of the human past.